Thank you. All right, so newscasters, weathermen like to talk about El Nino as something super, super scary, right? They like to get you scared about this sort of thing. And like you saw in that little video to start off the day, it is fairly scary. It's a scary event. You'll have more hurricanes in certain parts of the world. You'll have flooding, you'll have drought, you'll have wildfires. And all of this is because the ocean is changing because of El Nino. And I'll have to go back to that. Now, like it said in the video, it usually happens around Christmas time. They usually notice it. The fishermen off of the coast of Peru, they don't get the fish that they usually get. So everybody pretty much starves for Christmas that year. It's called El Nino, Spanish for the Christ child or the child, because it happens around Christmas. Now, ENSO is El Nino Southern Oscillation. Oscillation means to flip back and forth, all right? To just flip back and forth, kind of like a seesaw, teeter-totter, if you guys ever got to play on those. And again, I wish I could have thought this out a little bit more. So this is 2018. We'll look at 2018. You can see, now this is a picture, and you're going to see this some more. What we are looking at is the Pacific Ocean at the equator. You guys lock that into your mind. Pacific Ocean at the equator is where we are looking for El Nino. That's where the phenomenon happens. That's where it happens. Now look here, you can see SST, which are sea surface temperatures. But we're looking at the anomalies. This is how much they have changed from the normal. So if you have something really red like this, that means they are incredibly hot compared to what they normally are, okay? If you see blue, it's much cooler than it normally is. So we are not looking at temperatures here. We're looking at the difference from normal, okay? We know what the normal temperatures are. This little map, and if you look here, this is South America. There's Mexico. This is Mexico here. This is Australia and Southeast Asia. This is the Pacific at the equator, all right? And you can see all of this is happening, this heating up, much warmer than usual at the equator in the Pacific. Those are like key things. That's what you're gonna get if you don't get anything else. And I'll repeat it a couple of times. El Nino is warmer than usual temperatures at the equator in the Pacific, okay? So they look like worldwide. I'm gonna skip through that. Here you can see in 1997, 98, 2015, we had El Nino events. And this one, you can see the temperature of the water was in the white zone. So they were so much warmer than normal. Hurricane Patricia in 2015 was the largest hurricane with the highest winds ever measured in a hurricane. And it was because it was due to El Nino, that hot water firing it up. Exceptionally warm ocean water at the equator in the Pacific. Hang on, that's a thing we're not doing this year. How do El Nino and La Nina affect the weather? Well, changes in the ocean and in the atmosphere in the Pacific kind of has a ripple effect, like a butterfly flapping his wings in the Amazon, right? It changes things all over the world. And a little change there means big changes. So hang on, let me let some more people in. So this worldwide effect is conveyed by shifts in tropical rainfall and wind patterns over the entire globe, especially all countries surrounding the Pacific. So a typical wintertime pattern is El Nino. We have warm wind here. We tend to be wet and cool in the south, warm and dry in the northwest. You can see here, warm and dry. You can see different winter impacts, and it happens at Christmas. We're going to feel the impacts at Christmas. Effects on U.S. weather, positive. During an El Nino, we have fewer Atlantic hurricanes. We get winter rains here in Texas. You notice we haven't been very rainy at all. We need more rain. Still in a burn ban in Kendall County. Less wintry, so a mild winter. Since it's winter precipitation in the south, Florida doesn't get wildfires. But, so it's great for us in Texas. El Nino, booming business here in Texas. Less hurricanes, a little rain, so we get wildflowers in the spring. But if you live in California, where you're usually cool and damp, it's just the opposite. It's going to be hot, it's going to be dry, and you're going to get wildfires and just nastiness. Sometimes the negative for all the storms we get, you're going to get tornadoes. Okay. There's a nice little infographic telling you what's what. So during El Nino, you have drought, you have fires, wildfires. Oops, where am I? Drought and wildfires over here. Oops, who's here? Brianna. All right. You're going to have flooding on South America. You've got tornadoes, just havoc. This is a list of the things that happened during the 1983 El Nino. Now, La Nina is just the opposite, You have everything going the other way. La Nina, here's a tip, is a normal year on steroids. Everything is much, much more enhanced. Tends to be the opposite of those of an El Nino. La Nina, it's not like there's a girl child at Christmas, you know, no offense to all you girls out there, but it's usually the guy, El Nino. So they had to call it something, so it's just the opposite. You have El Nino, well, let's call this one La Nina. We have dry in the southwest, unusually cold in the northwest, and this means more hurricanes. That's something I ought to look up. Was this past year a La Nina? Because we had some hurricanes. All right, so that's just a very quick bit of notes for El Nino and La Nina. So what I'm going to do now is show you, stop share. This is, you know, I've got another one. What the heck? I got stuff going on here. Huh, I guess it's gone.
Every few years.
All right, so here we go. El Nino is difficult, so we're trying a different way since we can't physically show you what's going on. This is a model of what happens during an El Nino. All right, so again, we are looking at the Pacific Ocean at the equator around Christmas time.
Every few years, the El Nino phenomenon kicks into life in the Pacific Ocean around the equator. It can affect weather around the world, changing the odds of floods, drought, heat waves, and cold seasons for different regions, even raising
to see where we are, and sure enough, as you could tell by the amazing amount of hurricanes that we've had. We are in La Nina. La Nina conditions are present. So we're going to have a fairly dry winter. We had, as you know, lots and lots of hurricanes. It says it's supposed to continue through this winter, with possibly going to neutral, going back to normal in the spring. So hopefully we can do without the rain. I mean the hurricanes. All right. So if you look here, you remember that last one I showed you where it was lots and lots. No, I haven't. That's what I was saying. I'm working on them so that they're updated. We weren't going to put the notes in the folder at all, but I thought you guys needed something. So if you look here, let me present this. You can see, remember we saw at the equator for El Nino in 2018, it was very, very red. It was abnormally warm. Now, if you look at it right now, as you can see, this was over the weekend, it is abnormally cool. It's much, much cooler than normal. The trade winds are much stronger. And since the trade winds are much stronger, they are pushing that upper surface water over to the west, making this area over to the west much warmer than usual, while making this area over by South America and Mexico much cooler than normal. So again, this is the difference from the normal. Cooler than normal, warmer than normal. And that's what anomaly means, different from the normal. Okay, it's kind of cool. It's kind of cool that I was like, hey, we had a lot of hurricanes and it's not a very rainy winter. I bet we're in El Nino. And sure enough, we were. I'm going to get those in. I know a couple of you were wondering where are the notes. Now that I've fixed these, I'm going to put these in. So I'm going to get rid of all of the other stuff and make sure that you get the information posted. But I am now going to show you something that has to do with your assignment today. All right. Yes, it is another video, but this video is directly related to what you're going to do today and tomorrow. So those of you who came in late, remember, tomorrow is a testing day. You're only on campus if you're a sophomore taking the PSAT, or a senior, maybe juniors, I don't know, taking the ASVAB, if you're scheduled to take the ASVAB tomorrow. Those are the only people on campus. Everybody else, since I'm going to be working one of the two things, everybody else is going to be asynchronous. Don't log on, sorry, don't log on to Zoom. No Zooming tomorrow. You're going to finish the assignment that you get today, okay? And I will, once I tell you what to do and introduce the assignment, I'll get those notes in into Google. Okay, into Google. Oh my God, what a flashback to last year. Into Schoology. All right. So let me show you. I'll flip back and forth. All right. So your project is going to look like this. Cool, right? This is your project. And check it out. This is the video we're going to watch. So they are directly related. If you go back to the project that you're going to do, this animation video is the one we are about to start. I'm going to talk you through it. We're going to spend all of this week on El Nino, but it is a kind of difficult sort of weather pattern event that we're trying to describe to you, okay? So let me make sure I'm showing the video. Okay, so here we go. Look at that. Oh my gosh, it's the same thing. But in this animation, we're going to show you normal conditions. As you can see here, it's normal conditions. Oops. Normal conditions. This is what is supposed to happen. All right.
Animation, we're going to look at the cycle of El Nino and La Nina. That is a pattern that occurs regularly in the Pacific Ocean and has a huge effect on climate and rainfall and other kinds of activity all around
The guy's
much
not
of
like
the world,
terribly
especially around the Pacific Ocean.
charismatic.
Now, in order to understand the development of these two conditions, El Nino and La Nina, let's take a look at what the normal situation is in the Pacific Ocean. Normally what happens is that you can see those reddish arrows there. You get these very strong southeast trade winds blowing from east to west across the Pacific. By the way, this is North America over here, South America. This red line represents the equator. This is Australia and New Guinea, and Asia would be out of view on this side. So as these trade winds blow, the air eventually rises in low pressure systems and creates a lot of rainfall over on the west side of the Pacific, over near Indonesia. And
Remember, hot air rises, causing low
what happens
pressure.
is a circulation cell called the Walker cell is set up here that it basically runs like that. Well, the effect of that is to push the water away from South America. Ocean surface currents are pushed this direction, and that takes warm water and pulls it away to the west, and it lets cold water come up from below. Here we have warm water, the thermocline, the big change from warm to cold, and then cold water down underneath. And as that wind blows and pulls the water away from South America, you tend to get cold upwelling water near South America. Meanwhile, a lot of very warm water accumulates over here in the western Pacific. It's called the West Pacific Warm Water Pool, because that water takes a long trip along the equator and it gets very warm in this area. So this is a part of the world that's very wet and warm and rainy.
Okay, so that is if you've ever heard of a monsoon season, at this point, they're getting the rains over on that side because the trade winds are blowing the warm water. And when you have warm water, you have hot air that rises and gives you rainstorms. Okay, so this is the rainy side over here, and this is not. Yes.
So would it be a El Nino if we get a monsoon season? Because where I used to live,
If we get a monsoon season, yeah, if we have a really, really wet and rainy winter, then we're probably in an El Nino. Everything is swapped. And let's watch that now, because he's going to switch over to El Nino conditions. So everybody get a good look at this. This is normal conditions. This is how it's supposed to be. You have this trade wind, these red arrows here, the trade wind pushing the warm water over to the west. Hot air rises, and you get this circulation cell where the hot air is rising here and the cool air is coming down here. All right, so it's cool and dry over on this side. It is warm and wet and muggy and rainy over on this side. Since you have this water being pushed over here, it's piling up and pressing down. So this is the depth of the ocean. This is the bottom of the ocean, all right, the ocean basin floor. So you have water being pushed over here. The warm water piles up and kind of like a tube of toothpaste squirts the cold water so that it upwells here. Now, I don't know if you guys have heard the term well having to do with water. You know of a water well, I'm sure, but welling means that it's coming up to the surface. The only time you really, and that's why a water well is called a water well, because the water comes up to the surface there. It wells up, okay? The only time I've ever heard of it, and I do read a lot of horror movies, is when blood wells to the surface. You know, you get a really sharp cut and you look at it and you know you've cut yourself, but you wait a second and then the blood comes out, right? A really sharp cut. You have to sit there and wait for it. That's blood welling out of a cut. That's really the only two places that you use this term, except for now when you get to use it for upwelling. So this is upwelling. Of course, on this side you have downwelling. It's being pushed down. But this cold, nutrient-rich water is being shoved up to the top because it's got all the dead junk, dead animals and poop and stuff down in the cold bottom water. All of that fertilizer is being pushed up with the upwelling, which is awesome if you're algae, if you're a phytoplankton, if you're a photosynthetic organism living in that area. You're going, woohoo, party has started. And you start to expand and bloom, and you've got a lot of algae going on, which makes the plankton, the zooplankton, the animal plankton go, woohoo, look at all this food. And they eat, and then the fish eat those, and then the bigger fish eat those, and then the fishermen catch them all. And it's a wonderful, wonderful Christmas present for everybody. You've got fish for dinner, okay? So, dun, 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 El Nino. Let's watch what happens.
Whereas this part of the world tends to be cool and drier in general. Now, the whole reason this can happen is because these strong trade winds push this water from east to west. But if those trade winds break down, what can happen is all this warm water on this side of the Pacific Ocean can kind of slosh back across and pile up on this side. And that's really what happens during an El Nino. What happens during El Nino is the trade winds actually weaken and break down. It's called the Southern Oscillation.
Okay, remember, oscillation means like a teeter-totter. It's going back and forth. So this mind-boggling, because we've learned about the trade winds. The trade winds are constantly blowing, except during an El Nino. When they stop and sometimes can reverse. They can blow the wrong way.
And
check this out.
What'll happen is that water, that warm water, there's nothing to hold it back anymore, and it flows across the Pacific and kind of piles up over on this side of the Pacific, going all the way up toward California, all the way down to Peru and Chile. And
okay, so you see your high and low have switched places.
And the atmospheric pressure patterns switch. And so what happens now is that warm water fuels rain and storms, and the trade winds are actually reversed in direction. And this part of the ocean now becomes the rainy, stormy side of the ocean. And so during an El Nino, we typically have very high rain and lots of storms and flooding over on this side of the Pacific, from California on down to South America. Now, what usually happens within a year or so after the El Nino is that things kind of, it's like the pendulum.
Okay, hang on. He didn't talk about this. So if you look here, since we don't have this hot water being pushed over here and pressing down, we do not have this cold, cold water popping up. So there is no upwelling. That fertilizer, all that dead whale and poop and stuff like that, does not get brought to the surface. So you do not have happy photosynthesizing organisms and happy zooplankton who are eating those, and happy fish that are eating the zooplankton. All of it stops. There are no fish to be caught. The fish that were there either die or they go elsewhere. They follow the cold water. All right? Okay. So now he's going to talk about La Nina, which, like I said, we're in El Nino right now. He's going to switch it over to La Nina. Now, La Nina, like I said before, is normal conditions on steroids. The winds are stronger. The cold upwelling is bigger. Okay,
so swings back the other way, and we get a La Nina. La Nina really can be considered to be a sort of an intensification of the normal conditions. Remember, this is the normal situation where the trade winds are blowing all the water west and it's piling up over here. During a La Nina, the trade winds blow even more intensely, and even more cold water.
See, those arrows got bigger?
West, and even more intense upwelling happens along the coast of South America. So it really is just an intensification of the normal situation. So the Pacific Ocean kind of oscillates between these two conditions, the El Nino condition in which the water sloshes over to our side of the Pacific, bringing storms and rain and warm water, and the La Nina condition in which the water goes back to the other side of the Pacific and cold upwelling becomes even more intensified. These cycles go back and forth, not particularly regularly, but anywhere from every 2 to 8 years is pretty typical.
Okay, so let's look at La Nina. Remember, you've got the same, pretty much the same setup as normal, but you have much more upwelling. You see these arrows, they're much bigger, fatter arrows. The winds are stronger. Since the winds are stronger, it pushes the water, more water over. I don't know if you can see these rings around the high pressure, meaning it's much higher pressure, much lower pressure. So let me show you. Here's the normal, right? So what, we've got 3 rings here, 3 rings here for La Nina. Where are we? Let me go a little further. For La Nina, we've got more rings. 1 more ring, 4 rings, okay? So big upwelling, big trade winds, lots of water being pushed over here, making these storms even bigger. And this area much, much colder, okay? You'd hope there'd be a lot more fish too for those poor fishermen. So now Caleb has a good question. Do these events happen in the Atlantic? The Atlantic has its own oscillation, its own back and forth deal, and it's not as strong. It's not as big. If you look at, here, I'll put this up as a new share. So this is just a picture. So here is, Pacific's huge at the equator. It's enormous at the equator. If you look here at the equator, the Atlantic's not very big. So it doesn't have the large effect on the world. There is an effect, but we're not going, it's not very, if you're a meteorology wonk, if you really love that sort of stuff, you can look into it. Look into the North Atlantic Oscillation, NAO, and see what it does. But right now we are looking at this. So hang on, let me go to your assignments for tomorrow. All right, now, and then I'll put the notes in the folder. They're not very big notes, but those notes will go in the folder. And oh my gosh, I'm popping. Here's normal conditions, and you're going to have to recreate those. El Nino conditions. Notice I put it in red, so you remember that it's the hot one. All right, and then La Nina, again, blue. It's the cold one, okay? So I have these icons. So you've got the high pressure areas, you've got the low pressure areas. On this page, you're going to have to copy and paste. Like here, you can like make it bigger if you want to, or smaller, or whatever. All right. So you're going to copy and paste these, showing me where the rain is, where the sun is. Am I showing it? Is it not? Hang on. I am not showing it. I don't know what I was showing. All right. Here we go. Let's try this again. So it looks exactly like the video we just watched. I even labeled North America, South America, and Australia for you, so you know what's what. Here's the equator along here in the Pacific Ocean. You can see the depth, the hot water sitting on top, the thermocline, and the cold water beneath it. So this gives you directions. Here's what you're going to do for normal conditions. El Nino, it's red, right? Hot. La Nina, blue, cold, okay? So we have weather icons. You're going to make a copy. So you are going to copy. You're going to go up to here and paste. Paste on the equator where the hot air is going to be. Then you're going to put the cold, the low pressure. Hot, slow down. High pressure and low pressure. All right. Then you're going to come here and you're going to do the atmospheric circulation cells. Okay. Now, notice I've got two going in the same direction. I've got one going in the opposite direction. All right. You can see here, I've got just like regular sort of arrows. Here I got big fat arrows to kind of give you an idea of strength. And here I've got little weak ones going the opposite direction. So you're going to grab one of those. You're only going to use once, so you don't copy them. So we're going to copy that and paste it. Hang on. Come on. Hang on. Where's my movie thing? Got to move it. There we go. So you're going to move it in place. So high pressure is where the air is coming down. Low pressure is where the air is going up. Okay. Everybody's good? Interesting. Okay. And then you're going to put the upwelling in. So you're going to take this, you're going to copy it and paste, drag it so that it fits in the front of your little model. All right. Pretty easy, pretty self-explanatory. All right. Then for El Nino and La Nina, you can put the consequences. Here's flooding, here's fire and drought, here's live happy fish, here's dead fish. Okay. Everybody's good? Does it make sense? You guys are the first, you're the guinea pigs. All right. So at the beginning, I have the directions. You're going to use the clip art on slides 6 through 8 to copy and paste to set up each condition. Remember, all right, we only have about a few more minutes. You're going to do this for tomorrow. All right. This is your assignment for tomorrow. You can get started today, but if you notice, it's due tomorrow. See what you can do. The animation that I showed is on the front page, the animation video, and they will walk you through the whole thing. All right. Make sense? All good? Any questions? It's fascinating, right? Fascinating. Oh yeah, I was gonna set up the. Where's my La Nina, El Nino? All right.